Good afternoon, everyone. And I'm Rakesh Kumar from IIMT Engineering College, Assistant Professor in CSE department. And today now we are going to discuss about CPU scheduling algorithms. Basically, it's a basic part of how to schedule a process. When number of processes are in a ready queue, then what process takes first to execute uh, its program, or you can say it's a process. So this is the outline of our of today's session. First one is what is the process, and second thing is process state diagram and scheduling criteria, process schedulers, and number of scheduling algorithms. We will discuss one by one. So, what is a process? So, the process uh, from its creation to completion passes through various states and takes a minimum, and it has when a process from starting states to termination state, it passes through a number of states. First, first of all, we will create a process. So it is known as a new state, and after that, it moves to ready state and running state, waiting state, and terminated. So, what is a process, or what are the basic difference between process and a program? So, a program means that in simple language, or we can say in very layman language, a process is a program is a set of instructions until it resides in the secondary memory, or we can say in hard disk. While a program, while is a process, when it is in running state, it comes under the umbrella of a process. So these are some basic states of a process. First one is new, then ready, then running, or waiting, or terminated. So in this process state diagram, now a new process, when we create a new process, or when we want a newly coming process, okay, so it comes under the means that we know basically it's a new process, okay? And now after that it comes to ready state, means that we move to ready state, and how to the newly created process comes to new from new state, to new state, and now after a new state, how it moves to number of remaining states. So a new state means that a program which is going to be picked up from the OS. OS means that from the hard disk, or we can say from secondary memory to the main state, or we can say to the main memory. Main memory means that in the ready queue. So after creation of process, we moved it into the into the RAM from the hard disk, or we can say from secondary storage. So it's a basic funda of process creation when we want to run a process. Now, the second state is ready state. Whenever a process is created, it moves from secondary storage to RAM, or we can say secondary storage to primary storage. It directly enters in the ready state. So in which it waits for the CPU, or it waits for the CPU to be assigned. It waits after coming in the ready queue. In the ready queue, it waits until when, or we can say at what time that process will get a resource. So the OS picks the new process from the secondary storage, as I've told you, or we can say from secondary memory, and put it all to the main memory. Here it means that number of processes are resides in the main memory. Just because of we want to increase multi-programming. That's why we can store, or we can store number of processes, or number of processes in the ready queue, because we want to maximize as much as the CPU utilization. Now the third stage is running state. When a process gets the CPU once, it moves into the ready state. Now here we have two more things from running state to ready state. One is interrupt, and second one is dispatch. So interrupt means that any of the process is in the running state, and it may have, or it might have some kind of IO process, then it directly moves in from the running to wait state for its complete, for to its completion for IO event. Okay. Now, what about the interrupt? Suppose that a process is in running state, or we can say in continuancy for the running state, and any of the process after which is in the ready queue have a higher priority from the current state, then it directly then the running state interrupt itself, okay, and moves to the ready queue from the running state, and the new and the process that have higher priority, okay, from this from that running process moves to the running state and directly uh, executes its things. So this is the role of uh, interrupt and IO wait. IO wait basically means that when any of the running process wants some IO need, then it moves from running state to waiting state, and after that, as it completes its uh, IO need, it directly moves from waiting state to running state to complete its execution further. So now the third one is wait state. As I have told you, wait state means that from running state to wait state, a process can make its transition to block or wait state depending upon the scheduling algorithm, or we can say inherent behavior of the process. So we can say any of the process, just I have told you previously, wanted some kind of IO need. Suppose that if a process that is running, that is heading in the running state, and it have all type of resources, uh, so at that time, at the running state, it wants any type of IO, or we can say IO need. So it directly moves from running state to wait state, and after completion the IO, it directly moves from, after completion the IO, means that any type of thing it wants from the secondary storage, or any type of thing want to and any type of things which are mandatory to complete or we can say which are mandatory to for the termination before running. So it basically, after getting all type of things from this waiting state, and after completion the IO completion, it moves to ready state. Now, and the final one is termination, or we can say terminated. A terminated step is the last one step of process state diagram. So the process state diagram, in process state diagram, as a process gets um, as the process executes or finally executed, is all the it's all the step, it moves to uh, terminated step, or we can say last state from the running state. So this how, so this is all about the of a process, okay, from running state to terminated state, where, so we can say in a nutshell, a process starts from the new state, and after that after this it moves to ready state. After, as the process in ready state and gets the resource for its execution, it moves to running state, and from the running state, if it completes its execution, it directly moves to terminated state, or we can say last state. Or if it needs some kind of IO, it moves directly waiting state, and after completion the IO or any type of input output, okay, directly moves to ready state, and once again moves to running state for its completion. So here some basic steps of a scheduling criteria means that CPU utilization. The main goal of the CPU scheduling is to maximize the CPU utilization. And the second one is throughput. Throughput means that processes that complete their execution per unit time, means that how many process executes in per unit time. It may be a single process, or it may be a number of process over there. So, and the third one is turnaround time. The amount of time to execute of a particular process, means that when a process gets all type of resources in the running state, sorry, in the ready state, and it moves to running state. Now, the amount at which that process gets completion, or we can say get completed at the running state. Now, and the fourth one is waiting state, the amount of time a process has been waiting in the ready queue. So ready queue means that when a process already in the running state, okay, and the number of process are reside directly in the primarily in the ready queue. So means that suppose we have suppose for we have a single printer and number of process are want to execute over the printer. So as we can say, process P1 have number of 5 uh, process P1 have 5 pages to print it. So after printing the all pages at the running state, the new process, or we can say process P2 will get the process. So the waiting time means that how much time it waits in the waiting state, in ready state to get all type of resources. Response time means that the amount of time it takes from when a request was submitted, means that from ready queue to termination. Okay, it is the response time. So process schedulers, there are basically 3 types of process schedulers, and the role of process schedulers means that to schedules the process, means that which one process gets the CPU first, or we can say which one CPU gets the resource first. So there are 3 types of processes, the long term, or we can say job scheduler, and the second one is short term, or we can say CPU scheduler, and last one is mid term scheduler. So CPU scheduling decisions may take place when a process switches from running state to waiting state. Means that any of the process, means running state means that here on the slide, means that running state to means that waiting state. When any of the process wants to switch or wants to any type of IO need, then indirectly moves from running state to waiting state. And the second point is switches from running state to ready state. At what time it moves from running state to ready state means that any type of higher priority scheduling resides in the ready queue, then it directly moves from ready state to running state to ready state. And the third point is switches from waiting state to ready state. Waiting state means that any of the process in the ready state wants to IO need, then it directly moves to waiting state, and after completion the IO need, or after fulfilling the IO need, it directly moves to waiting state to ready state. And last one is terminates. As the process executes its all types of things, then it directly moves from running state to termination state. So this is the first scheduler, means that long term scheduler. It brings the new process from ready state. Ready state means that from secondary storage to primary storage directly. So it controls the degree of multi-programming. That means that the number of processes present in the ready queue. How much number of processes are present in the ready queue. So basically the main motive behind this is to maximize the utilization of a CPU. Now the second one is short term or CPU scheduler. It is responsible for selecting one process from ready state for scheduling it on the running state. Means that we are ready to give all type of resources for a particular process. Then the CPU scheduler will take a process from ready state, and it moves that process from ready state to running state. And the second point is short term scheduler only selects the process to schedule. It doesn't load process or on running. Instead, it does not force any process. And the third point is the dispatcher is responsible for loading the process selected by short term scheduler for the CPU at the running time. Dispatcher means that it dispatches from number of processes. Means that it dispatch, or we can say it push any type, any of one process from ready state to running state. Now the last one is midterm scheduler. It is responsible for suspending or resuming the process. Any of the process suspended from the ready queue, it works on that process. Which one is? Which one scheduler is? Midterm scheduler. It mainly does sweeping. Means that sweeping means that moving processes from main memory to disk and vice versa. Sweeping may be necessary to improve the process mix, or because a change of memory requirement, or we can say overcommitted available memory, requiring memory to be freed up. Now, so midterm scheduler basically works on the only when a process basically when any of the process need IO to complete its execution, then the midterm scheduler works over there. Now, as we as we have a number of scheduling algorithms, basically before moving this step, there are two types of scheduling algorithm. First one is preemptive scheduling algorithm, and second one is non-preemptive scheduling algorithm. FCFS is basically a non-preemptive scheduling algorithm. And what is preemptive and non-preemptive? So preemptive means that when any of the process is in running state, okay, and there are two causes of to be a non-preemptive to preemptive. First, the first reason behind this non-preemptive preemptive means that if any of the higher priority process wants to run its wants to complete its execution, then it become from non-preemptive to preemptive. Or we can say when any of the process want to fulfill its IO need, then it becomes then or we can say then non-preemptive process becomes a preemptive process. So preemptive and non-preemptive, there are two kinds of algorithms, and the FCFS means that first come first serve. First come first serve is basically a non-preemptive scheduling algorithm. So once a process means that in non-preemptive, once a process starts its execution, it will stop after its completion. In between, it will not stop. So FCFS means that whichever, or we can say whichever process enters the enters the ready queue first, it's executed first. So here we have three number of process P1, P2, P3, and arrival time is 0, 1, 2, 3. Burst time is 6, 4, 8. Now basically arrival time means that when a process arrives in the ready queue, arrival time counted over there, and the burst time means that how much time it will take to execute its for its completion, for its completion, or we can say how much time uh, that a particular process wants a particular resource. Means that if a process have arrived at zeroth time, so and it have number of pages like 6, suppose that process P1 have wants a printing statement and it has 6 pages over there. So at zeroth time, it will takes the resource, and after completion means that as it will print all the pages, means that 6 pages, it will release automatically the resource. So here we have three process P1, process P2, and process P3, and the arrival time is 0, 1, 0, 1, 2, and the burst time is 6, 4, 8. So at zeroth time, the process P1 enters in the Gantt chart. This is the Gantt chart. So process P1 enters in the Gantt chart, and the execution time, or we can say the burst time of that particular process is 6. And after this, the process P2 will come. So just see over there, as the process P1 takes 6 unit of time to complete its execution, process P2 and process P3 automatically have arrived in the ready queue. Means that after this, they will execute over the resource. So process P2 have arrived already over at the time of 1, and process P3 have arrived over at the time of 2. So process P2 will execute only 4 units of time, and process P3 will execute only 8 unit only 8 unit of time. So the finish time, or we can say the completion time, means that the right side of the process of a particular process. So right side of a particular process means that, as we have seen over there, process P1 has completed, or we can say process P1 have terminated at time 6. So what will be the a completion time for a particular process means that 6. So so the finish time, or we can say completion time for process P1 is 6, and the completion time for process is 10, and the completion time for the process of P3 is 18. So this is the completion time. Here I mentioned the completion time, so don't worry about the completion time or finish time. They both are same. You will see in number of books, somewhere you will find the finish time, or somewhere you will find the a completion time. So this is the basic formula of turnaround time. Turnaround time means that completion time or minus arrival time. Means completion time means that how much time it will take to execute its all the process or its all the things, minus arrival time, at which time that particular process takes the resources of any kind of resources. So 6 minus 0 is 6, and for P2 10 minus 1. So 10 minus 1 is 9. So this is turnaround time. So here 6 minus 0 for process P1, 6 minus 0 is 6, because arrival time of that particular process is 0, and the arrival time of process P2 is 1. That's why completion time minus 1 is 9, and for the last process, the finish time is 18, or we can say completion time is 18, and the arrival time for process P3 is 2. That's why 18 minus 2 is 16. So this is turnaround time for all the process 6, 9, 9 and 16. Now, what is the waiting time? Waiting time means that turnaround time minus burst time. Turnaround time means that how much time it resides, or it executes over a particular resource, minus burst time. So turnaround time for process P1 is 6, and burst time, and the burst time is 6. So 6 minus 6 is 0 waiting time, and for the second process, turnaround time is 9, and burst time is 4. So 9 minus 4 is 5, and for the third process, turnaround time is 16, and the burst time is 8. So 16 minus 8 is 8. So this is all about the FCFS algorithm, means that first come first serve algorithm. Now the second one is shortest job first. Shortest job first is basically a non-preemptive algorithm. Basically, there are two algorithms: shortest job first and shortest remaining time first. We can say SRTF. So shortest job first is non-preemptive algorithm, while SRTF, or we can say shortest remaining time first is preemptive algorithm. So we have like a FCFS algorithm, but what is the basic difference between shortest job first and FCFS algorithm? In FCFS algorithm, the process executes on the basis of arrival time, while in the shortest job first, processes executes on the basis of burst time, even though it follows the criteria of arrival time. Now, here we can see that there are three processes, A, B, C, and arrival time of these processes 0, 1, 2 respectively, and the burst time for the process of A is 3, and for the process of B is 4, and for the process of C is 6. So at 0th time, the process A will arrive in the ready queue, and if the resources are free, then it will directly move from ready queue to running state and executes over there only for 3 units of time. Because and one more thing, the burst time of this of process A is 3. This is the least burst of time from from all the processes, and the second least first time is 4, and the last first time is 6, means that highest first time process is C. So they will execute indirectly. So now here the completion time, just wait for this. And so the completion time for the process of A is 3, and the completion time for the process B is 7, and the process and the completion time for the process C is 13. As I have told you, how you will write directly the completion time means that we can say the right side of that particular process, means that for for process C, the completion time is 10, and for the SRTF, this is SRTF, and this is SGF. For the process C, the completion time is 13. For the process B, the completion time is 7, and for the process of A, the completion time is 3. Here you may also write the completion time. And what about the turnaround time? As I have told you, the formula of turnaround time means that completion time minus arrival time. So the completion time for this particular process of A, 3 minus 0 is 0, and the turnaround time for process 2, or we can say for process B, is completion time minus arrival time. So 7 minus 1 is 6, and for the last process, that is C, 13 minus 2 is 11. Now, what about the waiting time? As I have told you, the waiting time is turnaround time minus burst time. So same thing we will repeat over here. Turnaround time minus burst time is 3 minus 3 is 0, and for the process B, 6 minus 4 is 2, and 5 minus 6 is 6 minus 5 11 minus 6 is 5. So this is all about the shortest job first, and once again, this is a non-preemptive algorithm. Now the third one is SRTF, or we also say that shortest remaining time first. So shortest remaining time here first means that first of all it is a preemptive version of SGF algorithm. Preemptive version means that as a process have some shortest time for the current executed process, it will take the resources, or we can say it will take all kind of resources, okay, that are already have, or we can say that are already held by some kind of and the process. So here we have 3 processes, A, B, C, and the arrival time of all the process are 0, 2, and 3 respectively. Burst time for these processes 1, 3, and 5. So here we see over there the process A arrives at time 0, and it executes its burst time, that is 1. Okay, now we can see over here there is nothing at time 1 because process B will come at time 2. So at G1 to 2, the process will sit idle because there is nothing in the ready queue, because process B will arrive at time 2. That's why the CPU will idle at 1 to 2, means that for that particular span of time. This is the span of time. Here the CPU will sit idle. Now it is 2. Now the process B will arrive in the ready queue, and as you had seen, all the resources are empty. It directly moves from ready state to running state and completes its execution. So it completes its execution up to 3 unit of time. As the process B is executing, okay, here the process C will automatically arrive in the ready queue at time of 3, because process 2 as it executed at unit 1, means that it becomes from 1 to 3. The process C all have arrived to ready queue, but did not execute it over there because the burst time of this process C is 5, and the remaining time for this process, because it executed already 1 unit of time, is 2. That's why it executed continuously, so up to 5. Now for the process C, it takes only 5 unit of time and become 5 and 5 to 10. Now once again, for the completion time, or we can say finish time. So the finish time for process A is 1, and the finish time for the process B is 5, and the finish time for the process C is 10. Now turnaround time means that completion time, or we can say finish time minus arrival time. So 1 minus 0 is 1, 5 minus 2 is 3, and 10 minus 3 is 7. Now what about the waiting time? Waiting time means that turnaround time minus burst time. So 1 minus 1 is 0, 3 minus 3 is 0, and 7 minus 5 is 2. Here, the last one is round robin algorithm. Round robin algorithm basically plays over a time quantum, or we can say some kind of time slice. So time quantum tells us how much time it will take, or we can say how much time a particular process will decide in the running state. Basically, it's a cycling process. So in this, we have number of processes, means that A, B, C, D, and the arrival time of these processes are 1, 0, 1, 2, 3, and the burst time for this process are 0, sorry, 2, 4, 6, 8. And here we have time quantum of 2, means that any of the process that is running, that is residing in the running state will execute only 2 unit of time, means that the process will execute only in one cycle. Process B execute in 2 cycles. Process C is execute in 3 cycles, while and the last process D is execute at 4 cycles. So because we have time quantum of 2, that's why. So process A will arrive at 0th time, and the burst time of this process is 2, and the time quantum is also 2. That's why it executes all the things, or we can say it executes 2 unit of time. Now the second process B, and the burst time for this particular process is 4, but it will execute only 2 unit of time, and the remaining time and the remaining burst time for the next time is 2. And after this, the process C will come and executes its execution, or executes its burst time for only 2 unit of time, and the process D will arrive in the ready queue, and it will take the resources for 2 unit of time, and it will be continuously. So once again, what is the completion time for a particular process? So for the completion time for a process A is 2, and the completion time for the process of B is 10. We do not write over here 4, because here at 4 unit of time, process B will not, process B has not complete its execution, because here we have executed only 2 unit of time, but the complete execution for process B is 4, and even we have only 2 unit of time have executed. Here we have executed the complete execution of this particular process, that is B. So the completion time for process B is 10, and the completion time for the process C is 16, and the completion time for the process D is 20. Once again, the turnaround time is completion time minus arrival time. So completion time means that finish time. So 2 minus 0 is 2, and 10 minus 1 is 9, 16 minus 2 is 14, and 20 minus 3 is 17. And last one is waiting time. Waiting time means that turnaround time minus burst time. Once again, 2 minus 2 is 0, 9 minus 4 is 5, 14 minus 6 is 8, and 17 minus 8 is 9. So this is all about the round robin algorithm, and this is all about the some basic steps we have performed over the CPU scheduling algorithm. Thank you, and thanks a lot.